Hello friends, welcome to APM Stats Connect. Today in this video, we will discuss about the uniqueness of UMP test, that is uniformly most powerful test. We have already discussed about most powerful and uniformly most powerful test in our testing of hypothesis lecture, and the link is given in the description box. Okay, so UMP are not unique, and here we will prove it using an example. So first let's consider a random variable. Okay, so let x follows uniform 0 theta. X follows uniform distribution over 0 comma theta, and consider the problem of testing h naught theta less than or equal to theta naught against h1 theta greater than theta naught. So the distribution uniform 0 theta, it satisfies monotone likelihood ratio property in Xn, that is the maximum order statistic Xn. Okay, so let's write uniform 0 theta, it satisfies MLR, that is the monotone likelihood ratio property in the maximum order statistic Xn. Thus, using Cardin-Rubin theorem, the UMP test for testing against H1 with a size alpha is given by phi of x equal to 1 if xn greater than theta naught into 1 minus alpha power 1 by n and is 0 otherwise. Okay. So phi of x is the UMP of size alpha for testing H0 against H1 and is obtained using Cardin-Rubin theorem. Now let's find the power of phi of x, which is given by beta phi of theta, theta belongs to theta 1, is equal to 1 minus theta naught divided by theta power n into 1 minus alpha. So the power of the UMP phi of x is equal to 1 minus theta naught by theta whole power n into 1 minus alpha. Now let's consider another test function phi star of x and we define phi star of x equal to 1 if xn greater than theta naught and alpha if 0 less than xn less than or equal to theta naught. Now let's check the size of the test phi star of x, which is given by the expected value of phi star of x when theta belongs to theta naught. It is the size of this test phi star, theta belongs to theta naught, which is equal to 1 into probability that xn greater than theta naught plus, okay, so the given condition under the we are finding the expectation under the condition that the theta belongs to theta naught. So we will write it as, here we will write under h naught plus alpha into probability that 0 less than xn less than or equal to theta naught under h naught, which is equal to, under h naught the value of theta is less than or equal to theta naught. Hence, the probability that the maximum order statistic will lie greater than theta naught is equal to 0, because for uniform 0 theta, the value of x lies between 0 and theta. Hence, xn is less than theta. So under h naught, since theta is less than or equal to theta naught, the maximum probability that the maximum order statistic will greater than theta naught is equal to 0, plus alpha into the probability that 0 less than xn less than or equal to theta naught. The probability that the maximum order statistic will lie between 0 and theta naught. For uniform 0 theta, it is equal to 1. So the size of the test phi star of x is given by 0 plus alpha into 1, which is equal to alpha. So both phi and phi star of x are of size alpha. Now we will find the power of the test phi star of x. Consider the expected value of phi star under phi star under theta belongs to theta 1, which is equal to 1 into probability that xn greater than theta naught under h1 plus alpha into probability that 0 less than xn less than or equal to theta naught under h1, which is equal to, this probability is integral xn greater than theta naught. So integral from theta naught to theta, we can find the density function of xn using the result fn of x is equal to capital F of x whole power n, where capital F of x is the distribution function of random variable capital X. So the density function of xn, where x follows uniform 0 theta, is given by n into xn power n minus 1 divided by theta power n dxn plus alpha into integral 0 to theta naught n into xn power n minus 1 divided by theta power n dxn, which is equal to n by theta power n for xn power n minus 1. The integral is xn power n minus 1 plus 1 divided by n minus 1 plus 1, that is xn by xn power n divided by n ranges from theta naught to theta plus alpha n by theta power n into xn power n divided by n divided by n ranges from 0 to theta naught, which is equal to we can cancel n here and the remaining putting the value for xn, we have theta power n minus theta naught power n divided by theta power n plus alpha into theta naught power n divided by theta power n, which is equal to, we can take theta naught power n by theta power n common, which is equal to 1 minus theta naught by theta power n into 1 minus alpha. So this is the power of the test function phi star of x. Okay, so here you can see that the power of both phi of x and phi star of x are equal. Also both the function phi of x and phi star are of size alpha. Thus by definition of a UMP test, here we can say both the phi of x and phi star of x are UMP for testing the given testing problem H0 against H1, and hence the UMP is not unique.